to 6.1, the mole. The mole concept, okay. See, the concept is pretty, what you need to know about mole concept is, see, this is actually, in fact, the mole, it is a quantity, it is just a number, okay. Same way, what we call it as 1 dozen. 1 dozen, we know that it is actually a 12. 1 pair, it is actually known as 2. And so this is what we know about, one same way, like 1 pair, 1 mole. It is 6.023 into 10 raised to 23 number of particles. If you are taking total number of particles, total number of anything, this is nothing but a dozen. And 2 particles, this is nothing but one pair. So 1 mole, it is 6.023 into 10 raised to 23. Okay, so this is actually 1 mole. Now we will see how this particular digit, how it has come. See, the mole is actually, you know that, 12 atomic mass unit of carbon is equal to 12 gram. That means if you take 12 gram, this is actually 12 atomic mass unit, or else 1 by 12th of the atomic mass unit. We already learned it, right? 1 by 12th of atomic mass unit, it is actually 1 by 12 gram. So we know that. Okay. So yeah, so this is 1 by 12th of 12 AMU of atomic mass unit of carbon, it is a 12 gram, or it is going to be, so 12, this is, in fact, we know it is actually gram atomic mass, okay. So if you count the particles, actually, if you count the carbon particles in 12 gram, okay, how many carbon particles are there in 12 gram? Okay, so that is going to be, this is going to be, 6.023 into 10 raised to 23 number of particles will be there. That means if you take 12 gram of carbon, this is going to contain 6.023 into 10 raised to 23 number of carbon particles. Actually, this is a huge number. See, suppose 1000 gram. 1000 is actually 10 raised to 3. 10 raised to, this is actually 1, 2, 3, 4, 5, 6, 7, 8. So this is 100, 10, 100, 1000, 10,000, 1 lakh, 10 lakh, 1 crore, 10 crore, maybe 1000 crore, 10,000 crore, 1 lakh crore, maybe. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can count up to 10 raised to 12. Okay, so the number of zeros we will be counting actually. So 10 raised to 12, this is in fact 10 raised to 11. So we can go up to 10 raised to 12. Okay, but you see, this is a huge number. This is a very big number. In fact, this number, if you are writing, it is going to be into 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these many particles will be there. These many particles will be there in Avogadro's number. This is actually, this digit we call it as Avogadro's number. So we represent, A represent Avogadro. Okay. Thanks to the Italian scientist Mr. Avogadro. So he found this number. What he said is 1 mole, this contain 1 mole of anything, 1 mole of any particle, it will contain this many number of particles. So this is going to be, we can shortly write it as 6.023 into 10 raised to 23. So 12 gram of carbon, this contains 6.023 into 10 raised to 23 number of particles. Okay, 6.023 into 10 raised to 23 number of particles will be present in it. And now what we can understand, see, same way, if you take a 24 gram of magnesium, see, the molecular mass of magnesium is actually 24 atomic mass unit, and if you are taking the gram molecular atomic mass, it is going to be 24 gram. 24 gram of magnesium, this contain, again same way, 6.023 into 10 raised to 23 number of particles. Okay. And the same way, see, Cl2. Cl2, its atomic mass is actually 71, sorry, molecular mass is going to be 71 gram. So this contains 71 gram of chlorine. It contains 6.023 into 10 raised to 23 number of particles. So like a molecular mass of water, H2O, we all know. So molecular mass of water we have found in previous examples. So this is going to be 18 gram. So if you take a 18 gram of water, so this is going to contain 6.023 into 10 raised to 23 number of water molecules. Okay. So please remember that. So the mole is just like a pair, just like a dozen, it is just a number. So if it is this is actually 6.023 into 10 raised to 23 number of particles are there. 6.023 into 10 raised to 23 number of particles are there in this one mole. Okay, and 18 gram of water. So this is actually if you are taking its a mass. Okay, so now we will do some calculations. Calculations involving mole. Okay, see, number of moles is equal to, you please remember this, mass divided by molecular weight or mass divided by atomic mass. Okay, so this is what you need to know. And then, so suppose if I am asking you, please remember this this particular concept. See, if I am asking you, suppose 40 gram of, let it be 20 gram of NaOH. If I am giving you 20 gram of NaOH, how many number of moles are in it? How many moles will be present in it? See, number of moles, it could be 20 divided by, so the molecular mass of NaOH is equal to, this is going to be 40. So this is 20 divided by 40 will come. So this is going to be 0.5 moles. Okay, 0.5 moles it is going to come. Okay. And suppose if I am giving you how much is the mass of, let it be another question, how much is the mass of 0.5 mole of H2O. See, now we will see. Here actually they given N. N is nothing but like a number of moles. So it is let it be N. N is actually 0.5. So mass they are asking. How much is the mass? Molecular weight of water, we know it is 18 gram, right? So like a mass, it could be number of moles into molecular weight. So this is going to be 0.5 into molecular weight, it could be 18. So this is actually 9 gram. Okay. So this is how it is coming. Now, next one is, let it be, if it is from another question from your book itself. How many moles of oxygen molecules are in 64 gram of oxygen? So, 64 gram of oxygen they given you. 64 gram of oxygen molecule they given you. How many moles are in it? So they want you to know actually how many moles. So please remember this one. So number of moles you are familiar, it is actually mass divided by molecular weight, right? So 64 gram of oxygen. So the molecular mass of oxygen actually 2 into 16. 16 is the gram atomic mass of oxygen. So this is going to be 32 gram. So mass is actually 64 divided by 32. So this is going to be 2 moles. Okay, so this is how it is going to come.